Hey class, so we've been working with systems of equations on Friday and Monday. Tonight we're going to watch a video about systems of equations with special cases. You saw a few of these in the work on Friday with our parallel and coinciding lines. If you'll turn to the tab that talks about independent systems mean they have a single solution. These are the kind where they intersect one time. Okay, under the first tab with our independent systems, we have two equations. Remember, it takes at least two equations to make a system. Our first equation is y equals 2x plus 1, and our second equation is y equals 7 minus x. We are not going to make tables for these. We are just going to be graphing these on our coordinate plane to find where they intersect. So you do not have to make a table of values. We are just going to graph these. Okay, our first equation, y equals 2x plus 1, is written in slope-intercept form, y equals mx plus b. Remember, when we graph these, we always start with what is being added or subtracting. That's our beginning. We're going to start at positive 1 on the y-axis. So on our coordinate plane, put a dot at positive 1. Our slope is 2. To make 2 a rise and run, we're going to put it over 1. So we rise 2, run 1. On our graph, starting at positive 1, we go up 2, right 1, up 2, right 1, up 2, right 1. And then when we run out of space, we're going to go the opposite direction. We could go down 2, left 1, down 2, left 1. So here is our first line. It has a positive 2 slope, and it goes through positive 1 on the y-axis. Our second line, we have y equals 7 minus x. For this, we can rewrite it with our x in front. So we're going to put y equals, the x was negative, so it's negative x plus 7. Now, our slope is the number in front of x. We need to put a 1 here, so that's a negative 1 slope, and it begins at positive 7. On our graph, we're going to put a point at 7 on the y-axis. That's our y-intercept. To make our slope a fraction, we have negative 1. We're going to put it over 1. That tells us to go down 1 and right 1. Negative 1 on top tells us that we're rising down. And the 1 on the bottom of our fraction, our denominator, tells us to run to the right. So we go down 1, right 1, down 1, right 1, and we keep going. And then we're going to draw a line through our ordered pairs, all the way across our graph with arrows on the ends. Notice these two lines are intersecting lines. Their solution is where they intersect. So we have our solution right here where our two lines cross. I didn't draw a very good line, but it's where our two lines cross. The ordered pair for our solution is 2, 5. This is an independent system. It only crosses in one spot. Looking at our next tab, a dependent system has infinite number of solutions. So a dependent system has an infinite number of solutions. Turning over the tab with our dependent systems, we have two equations, y equals 1/2 x plus 2 and 2y equals x plus 4. Now, our first equation is already in slope-intercept form, y equals mx plus b. We need to write our second equation in slope-intercept form. We're not going to use our tables. We are just going to use the equations to graph these. So we have 2y equals x plus 4. The coefficient of x right now is 1. Write your 1 in front of x. We're going to solve this equation for y. Now, to solve this for y, we divide by 2. That's the number in front of y. And I divide everything on the other side by 2. The 2's cancel out. We get y equals, now on my equation, 1x divided by 2, well 1 divided by 2 is 1/2, and then we put the x, and then 4 divided by 2 is 2. So our second equation is 1/2 x plus 2. Now, looking at our graph for these, the first equation was y equals 1/2 x plus 2. The second equation is y equals 1/2 x plus 2. We are going to graph both of these on our coordinate plane and find where they intersect. Y equals 1/2 x plus 2. We're going to start at positive 2 with a slope of 1/2. we're going to rise 1 and run 2. There's our first point. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Both of these are positive, so we're going in the positive direction. Or we could go down 1, left 2. Drawing a line through these points. There is the first equation graphed on the coordinate plane. Our second equation is y equals 1/2 x plus 2. We're going to begin at positive 2. We rise 1, run 2, rise 1, run 2. You notice that these two lines are the same line. This means that one line depends on the other. Now, in our equations, they had the same slope and they had the same y-intercept. If two lines have the same slope and the same y-intercept, they are the same lines. A word that we use for these is coinciding. Coinciding means they are the same lines. And this would have infinite solutions. So, dependent lines, dependent graphs, are coinciding and they have infinite solutions. Those three things mean the exact same. It means the lines are the same. Our last special case is an inconsistent system. Inconsistent systems have no solution. Our two examples are y equals 3x minus 3 and y equals 3x plus 1. We're going to graph these. We're not going to use the tables. We're just going to graph these two equations. Our first equation was y equals 3x minus 3. When we graph this, we are going to start at negative 3 on the y-axis. That is down here at negative 3. Our slope is 3. To make that a fraction, we put 3 over 1. So we're going to rise 3, run 1, rise 3, run 1, rise 3, run 1. And we have the graph of our first line. The next equation was y equals 3x plus 1. We're going to start at positive 1 on the y-axis, and we're going to have our slope. Our slope is 3 over 1. We make it a fraction. So we rise 3, run 1, rise 3, run 1, rise 3, run 1, or we can go down 3, left 1, and we're going to draw our line. Now, these two lines are parallel. They are never going to intersect, so there is no solution. So an inconsistent system, means that the lines are parallel and there is no solution. Now, looking at our equations, we can tell that these lines are going to be parallel because they have the same slope, but we know that they're going to begin in different spots because their y-intercepts are different. So if two lines have the same slope, they're parallel, but if they have different y-intercepts, there's going to be no solution. So the things you need to remember about your systems of equations. If you are finding the solution is an ordered pair that will satisfy both equations. If the lines intersect, there is one solution. They have to have different slopes to intersect. If their lines are parallel, there is no solution. That means they have the same slope but different y-intercepts. Those are called inconsistent systems. If the lines are coinciding, that means they're the same line. There are infinite solutions. They have the same slope and same y-intercept, and those are called dependent systems. Make sure you have all this for tomorrow, and we will see you in class.